Yeah.
Why would you call it to show you other math class?
I don't play it.
Now,
Play math.
when you're dealing with stuff in standard form, you guys have all seen this before. When you're dealing with these things, there are a couple of things that you have to understand what to do when you are graphing. When you are graphing quadratic equations, what you want to be able to do here, and you might remember this, the first thing you have is what will all of these graphs look like? Parabolas. They're either going to be up like a cup or down like a frown. Remember that?
Yeah.
The other thing with every single parabola, there is what you call the axis of symmetry. The axis of symmetry is what? Do you remember? Yeah, the axis of symmetry would split a parabola in two. It allows it to fold in on, for example, taking a piece of paper and fold it in half, so it's symmetrical on both sides. That means that every point on this side has a corresponding point on that side, and so on. So when you're graphing these things, there's a couple of steps in which you follow. Oh, probably do a little graphing. Take two of these.
Oh, sorry, Mike. What you do that for?
Take two of those and just pass them around. So when we're working with a quadratic in standard form, it'll look something like this again. Remember, it's y equals 2x squared minus 4x plus 8. I don't know what it is. Okay? When I take care of these things, what I want to do first of all is identify what my axis of symmetry is. Your axis of symmetry for every quadratic that's in standard form is, remember how I showed you it was a vertical line? What does every single vertical line start with as far as an equation is concerned? X. It's always going to be x equals something. Well, this axis of symmetry has the equation of x equals the opposite of b divided by 2a. Those a, b's, and c's are the coefficients. Okay? Now, when I say the opposite of b, and I'm looking at the equation y equals 2x squared minus 4x plus 8, my value of b in that equation is negative 4. You always go with the sign in front of it to the 4. So the opposite of negative 4 is what? Positive 4. So in this example, it would be positive 4 divided by, well, what's 2 times 2?
4, so 1.
So my axis of symmetry occurs at the line x equals 1. Okay? Now, when I'm dealing with a quadratic, sort of a little bit. When I'm dealing with a quadratic, if you guys need more paper, I got more. Need more? You guys probably can go over that.
I think Mike was dead.
When you're dealing with quadratics, this axis of symmetry is always a dotted line because it really isn't part of the graph. It's part that you use to help graph. So it's just always a dotted line. In this case, it's a vertical line through x equals 1. Now, the other thing about the quadratics is that your vertex will always, always, always lie on the axis of symmetry. So when I'm thinking about my vertex, that means my x coordinate for my vertex, my x coordinate for my vertex is the axis of symmetry. Well, what's your axis of symmetry? 1.
Is that an equal sign?
Yeah. Now my vertex is going to be at x equals 1, but then how do you figure out what y is? Yeah, just substitute in.
Yeah.
What's 1 squared?
1.
What's 2 times 1?
2.
What's 2 minus 4? Negative
2.
2.
2. Negative 2.
What's negative 2 plus 8? 6.
6.
So my vertex lies at 1, 6. Now I have a decision to make. Will this graph open upward or downward?
It depends.
It depends on what?
On one of those variables attached
Isn't it A?
It's the A value.
to it. A
Yep.
value, yeah.
The A value tells you if it opens upward or downward. Now, is A positive or negative?
It's positive.
So is it open up or down?
Up.
So this one's opening up like a cup
Like a cup,
because A is positive. Now, think about the vertex now. Is this a maximum or a minimum value at that vertex?
It's a
minimum. It's a minimum. What I want you guys to get in the habit of doing is labeling this out. There's a real big importance for that here coming up in the next few days. I want you to start identifying max mins. Now, in order to figure out what my next set of ordered pairs will be, remember, when you're dealing with a parabola, a quadratic, you're dealing with things that are called symmetric twins. What that means is that for every point on one side, there's a matching point on the other. So if I go one spot over to the right, or one spot over to the left, it should be the same value for y. Now, if I move over to the left one spot, what's my value for x? Left.
0.
0. If I use 0 for x, what's my value for y? 8. So then at 2, what's my value for y? 8. They're symmetrical. Since this is only one spot away, that has to be one spot away. Okay? When you're looking at graphing quadratics, you're looking to find what are called sets of symmetric twins. Each of those points are the equidistant from the axis of symmetry. Question?
Well, Derek has a question,
Derek? And then so on and so forth. What you would be able to do then is just substitute the value of 2 or substitute the value of 3 and figure it out from there. This one's just going to wind up going off our graph because I just made something up. Connect your dots, la 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 la. Does this graph have any zeros? Oh, I know. Why?
Because, actually.
Minimum.
Okay, go further with that. Gun? Doesn't touch the x-axis. All right? It doesn't have it. This is an unfactorable equation because it does not cross the x-axis. We would not be able to factor that. There are no roots. There's no zeros. These are types of vocabulary I want you guys to start thinking about because that's what we're getting towards. Okay? Math is vocabulary. Axis of symmetry, parabola, maximum, minimum. It's all vocabulary words that you don't think that there are vocabulary words. Okay? So we go into the other, that's our that's our first form for today. The next one is a little bit different. The next one is called vertex form.
People don't teach all the other teachers.
Sorry.
What's the first one?
Standard. The first one's called standard form. We're going to look at 3 different forms today. We've got the standard form, which is what you guys are all accustomed to seeing. That's because that's how you guys all learned how to factor. The other ones are a little bit new, but you're going to find out that they're really easy to work with. What I want you to see here with vertex form is, did you guys notice that our best friends in the whole wide world, A, H, and K again?
Not really.
Do you remember when we first talked about A, H, and K with the absolute value? We had a horizontal and a vertical shift. The H shifted it left and right, horizontal. The K shifted up and down, vertical. Yeah, you were there. I remember you there.
Not mentally,
But you were physically there at least, so that, you know, it's 60% of it. So here's what happens. Just like we did before, the value of A still tells you whether or not it opens up like a cup or down like a crown. The H and K now gives you the vertex. So let me show you an example. So we have y equals -3 x minus 2 quantity squared minus 4. And let's say that's the equation that we have. The first thing I want to do is identify my values of h and k. The values of h and k are going to give me this, my center. They're going to give me my vertex. Now remember, when you're looking at these things, remember we had x minus h. Is my h value -2 or +2? +2. So my h and k in this case would be 2, and what's my k value? -4, good. Remember, when you're dealing with h's and k's, no, we're going to see h and k in every single graph situation that we see from here on out. We have, obviously, quadratics. We'll have square roots. We'll have logs, exponential, trigonometric. I don't know, there's some other thrown in there as well. But every one of those h's and k's mean the same thing. Horizontal shift, vertical shift. It's always the opposite of the h value, so it's not -2, it's +2. And you always keep the k value, that -4. All right?
So you always switch to the H.
Always switch the h. That never changes. Okay? So now I know that my h and k is at 2, -4. So when I go to start looking at a simple graph of this, I go to 2 and -4. My value of A is -3. Does this one open up or down?
Down.
It's opening down. It is down like a frown. So that means this vertex is at a maximum or a minimum.
Maximum.
Don't be so sad.
Why would you just have it to maximum?
Turn that frown upside down. We need a hobby.
You can build lanes with this guitar.
No. Now, the other thing that's nice about knowing the vertex form is that I now know what my axis of symmetry is. What's my x-coordinate of my vertex? 2. So what's my axis of symmetry?
2.
No, just the axis of symmetry. 2. The maximum is 2, -4. The axis of symmetry is just x equals 2. So I know that I have that dotted line again through +2. Oops.
Wait, why is it down?
Because it's really not there. Your axis of symmetries are really not part of the function. They're not part of the quadratic part here. They're just there to help us graph. Yes, kind of like imaginary numbers.
Wait, didn't we do this in house before?
What's that? You might have, but you might have done it a little bit differently.
So do this again.
From here, I also know since I've got my vertex at 2, -4, if I pick really easy numbers, I'm going to be able to find out my symmetric twins. If I use 0, or better yet, you've got a calculator, right? Do you have a calculator button that says y equals? All right, go to your calculator. We have y equals, I think it was, move this up. We have -3 times the quantity x minus 2 squared minus 4. So -3, parentheses, x minus 2 quantity squared minus 4.
Yeah.
Go right to your table. Second table.
Oh, yeah,
Where are you
oh,
at?
that's so big. That's
Oh, there you
-7.
Now, we all agree that the axis of symmetry goes through x equals 2, right?
Yeah.
So what I want to do is move my table. I scroll through to find +2. But what I want to do on my graphing calculator is kind of put it in the middle. I keep continuing to scroll down. So right now, oops,
Yeah, Mr. Murphy, I didn't give you what.
Yeah, I did not get that.
I did, yeah, I got.
I got 0 is -4.
No, I got 0 is 0.
0 is -16.
I got that.
Double check how you typed it.
Yes, I did it wrong.
-3. I got it right.
I got what you got. I did not put those parentheses.
Here's what I want you to do. When you get to your table, put your axis of symmetry in the middle. Your table function will allow you to see 7 sets of ordered pairs. And if you think about it, guys, shh, If you look at what they're showing you, right there is my vertex. That value of 2 is also the axis of symmetry. So from here on out, when x is 1 and x is 3, they should have the exact y coordinate. When x is 0 and x is 4, they have the same coordinate. These would be considered, symmetric twins. 1, -7, 3, -7. There you have the same y coordinate and they're equidistant from that axis of symmetry. That's what you call a symmetric twin. So what you're looking for on the table here is just to find your pairs of the symmetric twins. You've got 1, -7, and then the next ones just kind of fall off the graph. And that's all you're doing. Use the calculator to help you find symmetric twins, because the bare minimum that I want you to be able to do here is identify your vertex. Is it up like a cup, down like a frown? Is it maximum or minimal? What's the axis of symmetry? And can you plot a couple of symmetric twins? Make sense? This is a new form. You haven't seen this very often. You're used to working with it in standard form. That's what you guys did in chapter 10 in your algebra books. Go through the whole long, drawn-out process of making tables and going through all that. You don't need to do that much work. You really don't. Okay.
Why did I not get what you asked? No, I don't want you to do it.
What do you got? Hey, what's up? What happened to this?
But like, I don't like the new ones, because like the A's and the F's, and then I use that one. Like, I can come back to one.
Yeah, no, somebody needs
Okay, would I be able to though, like, have for like a couple weeks?
couple weeks. There should, I don't know if you had enough of them. Check the library, but I'll take around for it. No problem. Sorry. So, in this case here, this is what you call the vertex form, right? Yeah. All right, let me show you the other one. There is one other form that we're going to look at today, and it's called intercept form. Yes, sir?
How do you know if it's facing up or down?
The value of A. If A is positive, it's up like a cup. If A is negative, it's down like a cup. And that works for all of these forms. Okay. When you're dealing with intercept form, you're basically dealing with a factored form of the standard. Okay. You're dealing with it already in a factored form of your standard. For example, if I wanted to factor out, let's see, x squared. Do you remember what this meant to factor that? What times what's -12 you add together to get +1?
Yeah.
You're nodding your head. What are the terms?
4 and -3.
Good. So it's x plus 4, x minus 3. From there, what were my zeros?
I struggle at this one.
Well, we're doing this for a long time, so I pay attention instead of playing with your bracelet.
-4 and 3.
-4 and 3. So where did this cross the x-axis? -4 and -3, or -4 and +3. When you guys were solving your zeros, when you were factoring in algebra, you were working with things going to intercept form. What they're doing here is they're giving you the factored form of a quadratic. Okay? They're giving you the factored form of the quadratic. And I'll use this example here. Y equals x plus 4, x minus 3 as my example. What that means is that, well, first of all, what's my value of A?
0.
1. If it was 0, it would all be gone. It would have y equals 0 on the horizontal line. My value of A is 1 because you don't see anything. When you don't see something, it is implied that it is 1. The zeros of this. Remember, when you're finding your zeros of something that's already in a factored form, you take the term and you set it equal to 0. So you had negative 4 and 3. That allows you to figure out where the quadratic is crossing the x-axis. So when you go to plot, move this around here a little bit. When we go to plot, we plot at our intercepts. I plot my intercept at negative 4 and positive 3. Will the vertex of this quadratic be above or below the x-axis? It's below because it's got to be up like a cup because A is positive. Does that make sense? I know that my vertex is going to be a minimum. I just don't know where it is. But I do know that I have two endpoints that have to be equidistant to what? The axis of symmetry. Now, if these two guys are going to be equidistant to the axis of symmetry, wouldn't the axis of symmetry be the halfway point between those two? What's negative 4 plus 3? What's half of negative 1? Negative 1/2. My axis of symmetry occurs at x equals negative 1/2. Once again, find your axis of symmetry when you are in intercept form. You take your zeros, negative 4, you add the zeros together and divide it by 2. It's the halfway point of them. They're equidistant. Okay? Yes, ma'am?
So why did you switch the signs?
I'm finding my zeros. When you're finding zeros, remember it's x minus p, so if it's x plus 4, that means it's the opposite. It's negative 4. X minus q means it's the same. So when it's, so if this is negative, this is positive, it's changed. It's just changing. You're finding the 0. What makes this equal to 0? What makes x plus 4 equal to 0? Negative 4. What makes this equal to 0? Positive 3. Okay? So here I know that my axis of symmetry occurs at x equals negative 1. Or 1/2, excuse me. So my vertex is at negative 1/2, comma, well, what's the other one going to be? What do you do? You substitute in and solve. Negative 1/2. What's the function? Plus 4 times negative 1/2 minus 3. So you have 3.5 times negative 3.5. I don't know what that is.
Aren't they both negative?
Let's multiply them together. What is it? 10 1/4 or something like that? 11 1/4? Negative 3.5.
It is 12.2.
12 1/4?
Negative.
So worst thing that happens here is we have a crummy little fraction. Big deal. Is it going to be up like a cup or down like a crown? Could you pick a set of points that are equidistant from that axis of symmetry to find a symmetric twin? Yeah. Let's pick 1. If I pick x equals 1, what's 1 plus 4? What's 1 minus 3? Negative 2. What's 5 times negative 2? There's 0. That means at... Yes, it is. 1 is 1.5 from negative 1/2. 2 is 1.5 away from negative 1/2. What you're doing is you're finding symmetric twins. Once again, my axis of symmetry in this case, oops, occurred at negative 1/2. Okay? The value of 1 is 1.5 away. The value of negative 2 the value of -2 is also 1.5 away. These 2 points are equidistant. Okay, that's what you have to start to play around with. That's the worst case scenario here, guys, if you wind up with an axis of symmetry with a fraction. Okay? Could you also use your table function on your calculator? Yes. And it'll spit it out for you. Okay. So my idea for today is to give you guys a couple of these problems. Let's try one more. Nope. We just did that. Let's try one more of these in intercept form. Vertex form is generally a little bit easier. Intercept form, you have to do a little bit more work. That's why I want to work on one more of these. Once again, I have y equals negative times the quantity x plus 2 times the quantity x minus 1. Get my a value is going to be -1. So I know it's going to be up or down. My vertex is going to be maximum or minimum. Okay. Where are my zeros going to be located for this function? -2 and +1. Do we agree?
Yes.
Okay. -2, +1. What's -2 plus 1? -1. What's half of that? -half. Remember, to find my axis of symmetry, take my 0, add it to the other 0, and divide it by 2. I once again get an axis of symmetry at -1/2. X equals -1/2. We know this is a maximum, so I know that my vertex should be above my x-axis. I just have to figure out where. So once again, we get, what is that? Negative times -1/2 plus 2. -1/2 minus 1. This is -1 times 1.5 times -1.5. So +2 1/4. Is that right?
Yeah.
So my vertex is at -1/2 and positive
Yeah,
2 1/4. About there. And it's just going to fall away. Okay? I still want you to get a secondary. For intercept form, you only have to find one other set of symmetric twins. Because you just use your calculator, you'll be fine to get those from the table. Willis?
Will we be going over this some more tomorrow?
Maybe. Why? No, we're actually gonna jump into 5. We're gonna check homework when we go right to 5 too. Factoring takes a lot longer to go through than this. All right. All I want us to be able to do tonight are the following 6 problems. What page is this? 253. What I want you to be able to do when you're graphing, there are 2 of each of these 3 types for a whopping 6 problems. I want you to label, write down vertex. Is it up like a cup, down like a frown, max, min? What's the axis of symmetry? The x equals some number. And I also want you to plot 2 sets of symmetric twins. Now, when you're using things in intercept form, you already have one set done for you. You just have to find the other. Use your table function if you have to. Okay?
Yes, sir.
Hopefully this isn't so scary, so bad. Tomorrow we'll probably jump into a little bit of how you can manipulate between the between the three styles. It's not the most convenient thing in the world, but then we'll start doing some factoring. Okay?